And welcome to Technology Live, the program that lets you ask questions of metrology experts. I'm your host, Dirk Ducharme, Editor-in-Chief for Quality Digest. Well, if you hear that buzz behind me, that's because there's a lot of activity here at the joint FARO Technologies and Carl Zeiss Industrial Metrology's booth here at IMTS in Chicago. And in this joint booth, you will find probably the best collection of metrology, precision metrology equipment in the world from two of the world's leading metrology equipment manufacturers, Zeiss and FARO. Now, if you've watched Technology Live before, you know what the show is usually about. It's usually about taking one or two pieces of equipment and really digging into them, really getting into the nuts and bolts of how the equipment works. Well, we're going to be looking at equipment today, but it's going to be from a different perspective. It's going to be from the perspective of one of FARO's and Zeiss's joint clients, and that is Pratt Miller Engineering. Now, if you follow motorsports, you're probably familiar with the Pratt Miller name. They've been put forth racing teams for both the American Le Mans Series Corvette racing, and you can see we've got a beautiful 2010 Le Mans Corvette sitting behind us. We're going to hear a little bit more about that in a few minutes. And they've also put up a racing team for the SCCA World Challenge Cadillac Racing. But Pratt Miller is a lot more than just fast cars. They are involved on high-end engineering projects for a variety of industries, including not just motorsports, but automotive, military, aerospace, and commercial. And with that kind of portfolio, they need all the best metrology equipment at their fingertips. And what we're going to hear today is how Pratt Miller takes equipment from two of the leading metrology equipment vendors, FARO and Zeiss, and uses those two pieces of equipment from those two vendors to solve high-end engineering problems. But before we get started into that, I'd like to introduce everybody who we have on the show with us today. So to my left is Frank Valdez. You are an applications engineer with Zeiss, right?
Yes, sir.
And we've worked together in the past on
Complex by Zeiss, yes.
By Zeiss for a Technology Live. And to my immediate right, I am really happy to have Frank Wilson. You're the Quality Assurance Manager for Pratt and Miller, right? Mm-hmm. And on my far left is Michelle Edmonds, Applications Engineering Manager for FARO Technologies. And you and I have worked together several times on a variety of FARO products.
Yes, we have. It's good to be back, Dirk.
Great. Well, Michelle, let's go ahead and start with you. Why don't you just give us a brief overview of FARO and what we could expect to see here at IMTS this year?
Absolutely. Well, FARO is a 30-year-old American company, and we are the world leader in portable 3D measurement. We are headquartered out of an office outside of Orlando, Florida. It's Lake Mary, Florida is the actual location, but we have a global footprint. We have offices throughout the world, in Europe, in Asia, in the Americas, both North and South America. And from this global footprint, we are able to support our customers, including Pratt & Miller, at a local level as well, with offices and FARO representatives spread throughout the globe. We can more easily contact our customers along the way. Some of the things that you'll see here at IMTS in our booth are the new Edge Arm. We released the Edge Arm a little over a year ago, and the newest version of it, debuting here at IMTS, has a latest release of onboard software. The Edge Arm is the first ever smart arm with an integrated touchscreen for quick measurements. And we're also debuting the Vantage laser tracker here at the IMTS show as well. So come on by the booth and see them both.
Okay. And by the way, just a reminder before we go any further here, if you have any questions during the show, be sure to email them to us. Remember, this is a live show, so be sure to email them to us at techno-live@qualitydigest.com. That's techno-live@qualitydigest.com. And we'll be sure to get to your questions on the show. So to my left here, we got Frank. So tell us a little bit about Zeiss.
Well, Zeiss is a company with a lot of history. We are the industrial metrology section of it. And our history there is actually pretty interesting. Zeiss started off making microscopes, and they needed special equipment to inspect that they're making their microscopes right. So what ended up happening, their inspection equipment was so good that they were able to create this whole new division of Zeiss that just sells industrial measurement equipment. So we're the first company to do scanning, and that means continuous touching of your workpiece while measuring, so no more touch points. Okay. So we're the first company to do that. We have locations across North America. We just recently opened a direct office in Southern California. That's where I work. And we have our headquarters in Maple Grove, Minnesota, where we have an assembly plant there. So if you buy Zeiss, you are indeed buying American. And we have a technical center that's heavy automotive in the Detroit area.
And now, just for some clarification, we're going to be talking about scanning, and you mentioned scanning, Your scanning is non-contact scanning. Scanning you're talking about is actual touch probe scanning. Continuous contact.
Yep.
Okay. All right. Well, let's get right over here to the meat of what we want to talk about. This is, again, Frank Wilson from Pratt Miller. Mm-hmm. And something that's unique is that on this show is that we actually have two different vendors, two very large metrology vendors who are vendors to Pratt Miller. And you're using both of their equipment to solve a wide variety of problems, not just in motorsports, but in a variety of applications. Mm-hmm. So why don't you tell us a little bit about that?
So Pratt Miller was founded in 1989 as a small motorsports engineering and manufacturing company with the target of running factory-backed road racing teams, which now we do in American Le Mans Series with Corvette, World Challenge for SCCA with the Cadillac. We also build cars that race in both classes of Grand Am, do support for NASCAR and IndyCar support for the Chevy-powered teams. So obviously the motorsports is a big portion of our business, but we've been expanding a lot into non-motorsports and applying all the tools and methods we developed there to things like automotive prototyping, electric vehicle development, defense development, even some medical device prototypes and things like that. So we're applying all of our tool sets that we've kind of forged in the fires of racing to all these non-motorsports applications.
Yeah, I think one of the more interesting ones you had mentioned to me earlier is something to do with a helicopter. Was that?
Yep. We actually went off-site to a military base to do laser scanning of a cockpit, so we could get a packaging envelope to design a new seat for the pilot and co-pilot, because the seat design is from basically the 70s. So with all the stuff we've learned, as engineers over the past 30, 40 years in terms of energy absorption, we can package a much better seat system for them in the event of a crash on the belly or something like that of the helicopter.
Now, I'm assuming that this involves some reverse engineering, right?
Yep.
So obviously, probably a helicopter that old, no CAD.
Yep. Okay. Well, no CAD from Sikorsky. It was a Black Hawk helicopter. So it's a helicopter that's been in service for a long time, and we're not working directly with that company. This is like a supplier upfit type of system. So we were working for a supplier, helping them do a packaging study just to kind of understand what kind of technologies they could use to develop a new seat.
So tell us a little bit about this car behind us.
So this is a 2010 Corvette C6R that races in the GT class in American Le Mans Series, and there are two GT classes in Le Mans. There's a pro and an amateur class. This car actually raced in the pro class in 2010 at Le Mans. This is an actual race car. It's been through some troubles. It's been in...
It's a little dinged up.
Yep, a little bit. It's still got its battle scars on it. It actually was in the biggest wreck we've had with one of these cars at the finish of a race in the last race of 2010. He went into the wall and it crushed the frame, but we were actually able to fix the front of the car and send it out racing for the next season. And we're able to double check and triple check that everything is all right after the repairs with all of the equipment that we get from FARO and Zeiss. So,
do you guys make a whole new car every year or every racing season?
It depends on what the plans are for GM. So it's kind of up to them. But typically we'll make 2 new cars each year for the program. And then we have customer teams. Our customer that races in the FIA World Endurance Championship is a French team, Larbre Competition, and they've won the amateur class at Le Mans the last 2 years with a Corvette. They have to run 1-year-old style because it's for amateur privateer teams, so they're not a full factory-backed effort, but they have our equipment, they have our engineering support, we have a European support guy that helps all the European teams. We have about 9 Corvettes racing in Europe now.
Wow.
The Europeans like the American Corvette. So
when you make a new one, is there a lot of design change?
Typically no. We might do a rev change for a part or something like that, an update, but usually we'll update those parts across the board. The chassis stays basically the same for the run of the car until we do the next generation.
We'll talk a little bit about how you use two different types of technologies. I mean, Michelle, Pharaoh's products are portable CMMs. Obviously, with Zeiss, we're talking about a bridge CMM.
Bridge type
right?
CMM.
Bridge type CMM. So tell us about how you use those two different technologies, let's say in different aspects of a car.
So when we make all of our body panel molds, a lot of them are machined out of resin tooling board. So they're designed to be done for low production volumes, but before we lay up molds or parts off of them, carbon fiber is very expensive, and the time it takes to make one of those parts is quite a bit. So we want to make sure that the mold is all correct. So we'll actually use laser scanning with the FARO edge arm and the laser line probe, and we'll actually scan the molds and do a topographical map to what we actually want, make sure all the interfaces between body panels are acceptable, and all that before we invest time in it. We'll set up our fixturing for the chassis. With the Pharaoh Arm, we'll actually use a magnetic base and put it in the middle of the steel bed plate and lay out our fixturing to get it within our tolerances before we start manufacturing the race chassis.
Let's talk about fixturing a little bit. I mean, it's interesting because I was just talking to somebody else here at Zeiss about the importance of fixturing. Talk a little bit about that and how you might use I guess the Pharaoh Arm to make sure your fixture is what you need before you get started even measuring.
Yep. So we'll actually start out with making small fixturing blocks for attaching dowel pins and things like that. So those will be precision machined for the dowels and all that. We'll actually inspect those on the Zeiss, and then they'll all get welded together. And then we'll inspect the entire weldment, which actually ends up being pretty big and heavy. It's robust, so it doesn't deflect when they're, the heat absorption when they're welding close to it doesn't affect it. So we'll actually inspect the weldments with the Pharaoh Arm, and then we'll actually lay them out, both the front and rear chassis cradle fixtures that mount the suspension, which is obviously critical to going fast around the racetrack, and then that'll ensure that the chassis is developed and manufactured to the design intent. We do a lot of pre-production simulation and iterations of suspension geometry to make sure that the first actual time money is spent making something, that it's correct. The fixturing is critical because there's no point in making, you can't make a good part without a good fixture, especially with the extent of weldments that we make, control arms, the chassis, including the roll cage, a lot of brackets that mount the bodywork, the bumpers and things like that. So all that stuff is critical to having, the overall package with all of the stack-ups of everything be a fast car.
Now, Frank, when you're putting the fixtures together and you're checking their locations after they're put together with the Pharaoh Arm, that's an important step.
Yep.
We also have the ability, and some of our customers utilize the technology to aid them in getting that part to exactly the right location. Are you doing that as well, using the real-time feedback to get you into that coordinate system?
We'll typically measure the fixturing locations, and then we'll just, without changing into a new file or anything like that, we'll actually just move it slightly, remeasure, see where we moved in X, Y, and Z. So I'm not familiar necessarily with that feature, but we might need to talk about that.
We'll show you after the show.
Well, you're at the right place, So let's get a little bit more specific now. We're going to talk a little bit about how Pratt Miller is specifically using some of the features and benefits of Pharaoh products, and then of course we'll come over here to Frank and talk about the same thing with Zeiss. So let's talk a little bit about the portable arms and kind of what that's buying for you in terms of your particular processes.
The great thing is we can move it around the shop. Sometimes we'll go over to where the race team actually works on the cars, and they'll have something that they're having a problem with, or they were in a wreck. They don't think it's bad enough to have to go back on the bed plate and have it, refabricated any parts. So we'll go over there and wheel our cart over there with the arm mounted to it and actually do measurements right on the car over there, and so they don't have to go through the hassle of moving the car, a couple of bays over. Usually they tear down after every race, so everything's really accessible. So that's great. We've actually taken it off site a lot. I've been to GM Proving Grounds with it. I've been to the military base with it. I know some of the other guys have taken it off site to do some support for some of the NASCAR teams. So it's used in a variety of off-site applications. I'd love to throw the Contoura in my backpack, but I can't quite do that. But Pharaoh makes great cases for transport and things like that to make sure you're not going to damage the equipment in transit and things like that. So
is it easy to get into the military bases with some foreign measuring device that most MPs don't know what it is.
When you've talked to the commanding officer, yes.
That kind of helps.
Yes.
It actually helps that many of the military installations do use our equipment as well.
Oh, cool.
Several of our customers are either suppliers to military or the Department of Defense itself. So they're familiar with our products. But yeah, usually coming through that first security gate, you do get a couple second looks when they look in the trunk of your car.
Yep.
Hey, since we're talking, we've been talking about kind of the portable CMM and the fixed CMM, kind of individually. Have you ever had an opportunity, or is there ever an application where you need to use two different technologies on maybe the same part?
Sometimes when we're doing machining of a part and it's in process, it doesn't look anything like it's going to in the end. We can't really use the program we've developed for the final inspection as easily, because usually there's extra material hanging off all over the place. So in order to inspect the in-process stuff, a lot of times we'll use the FARO arm. We've actually, on some of the parts, used the magnetic base and mounted it directly to the ways of the machine, in the machine, so that we could do an in-machine check on something. So that's a great aspect of the portability, and especially they have a variety of arm sizes. So we use the 12-foot edge arm, but the 6-foot arm that we have also works great for some smaller applications, and then for quick checks we also have a gauge arm. So
okay, actually we did just have a question come in kind of related, I think, to what you just said. Remember, if you have any questions, be sure to send them to techno-live@qualitydigest.com and we'll get them on the air. So this question, I think I understand what they're talking about. What are some examples of a time you, no, I'm sorry, wrong one. Why would someone scan with a FARO arm rather than a hard probe, or vice versa? And I'm not sure whether they're talking the scan arm or a hard probe on a FARO arm, or whether they're talking why would you use a scanner versus a CMM?
We actually use even on the FARO, both the contact and non-contact. A lot of times with the molds, it's the resin board is not really durable to have a probe dragged across it. We don't want to mar up the surface, so non-contact is great. Parts that have deflection and things like that, it's easier to get body work and things. Obviously carbon fiber is fairly rigid, but you can get some deflection because we're trying to make it as skimpy as possible and get away with it and have it be as durable as we need it. So there's definitely applications that sometimes we'll use both equipment, both laser and for profiles and things like that are not necessarily critical for function, but we want to make sure that the lightning pockets and things like that are done correctly on a prototype. We'll do a laser scan just because you can gather a lot of data quickly.
Sure.
To build on what he was saying, the hard probe, generally you get less data points, and you usually use the hard probe whenever your part is not going to deflect. With the laser scanner, you're looking for many more data points, hundreds of thousands of data points, as opposed to hundreds of data points. And the non-contact ability of gathering that information very quickly gives you a tight spread of data all at once, very fast.
I'm not sure which one of you is more appropriate for this question, but we've been talking about specifically on a race car. I mean, one of the questions that came in is how are FARO products used on consumer automobiles as opposed to some high performance vehicles? I mean, is it basically the same thing? I
would see that the function would be the same, the technique would be the same. I mean, you're going to want to, obviously mass production, you might have check fixturing and things like that, but when you're working up to that point, and prototype, which is what our business thrives on, is the prototype type level stuff. We've done for defense projects where we've done body work for vehicles, lightweight body work to increase their fuel range, allow them to carry more armor. I mean, that isn't really a consumer, but it's a higher production environment. And we'll apply the same mold scanning techniques and final part scans to compare that. Does it spring coming out of the mold? Do we need to modify coring and things like that? So I would think that could be applied, to sheet metal as well in the production automotive environment.
Well, Frank, let's turn over to you now. Let's talk about the Contoura, and you guys can have a little discussion here. How the Contoura is being used at Pratt and Miller, and kind of what makes that an ideal machine for this kind of environment.
So the way we chose the machine for Pratt and Miller was the VP of software actually went down to Pratt and Miller and said, "You need this machine." So when the VP of software says you need this specific machine, he knows what he's talking about.
Right.
So We're heavy in the automotive industry. That's where we have our location in the Brighton area, Detroit area. So cars are nothing that's new to us. So it only made sense that if you're making a high performance vehicle, you need a high performance CMM, high accuracy. So we take knowledge that we already know from the automotive industry and pass it on to guys like Frank at Pratt Miller. So what they have is a Vastex T Contoura G2 that they use to measure all their machine parts, and they use them for large production runs of any other thing that goes on there. So the advantage they get from having a CMM is it provides them a lot of feedback on their process. So let's say they're making a part, it doesn't just tell you whether something's in or something's out, whether it's made to spec or not. What it tells you is you get a lot more visual feedback. If something's off a certain dimension, certain size, it tells you where, it tells you by how much, and you can see all this. So even if he's making parts that are good, if there's room for improvement, ideas for improvement, he has data to back up any idea that he might have to, make something better.
Okay.
And so we provided a lot of great reporting tools for that. And regardless of industry, we like to provide great feedback for you guys.
Let's talk about that a little bit, because one thing we know is it's very easy to get caught up in the actual measurement hardware. I mean, everybody likes to see the arm and the scanner, or the CMM running and the probe coming down and taking these super accurate data or millions of points. But there's the other side of that, and that's the reporting. And I'm guessing your clients are getting more and more picky about the type of reporting they're getting. They don't want to know if something was just in spec or out of spec. They want some real details, right?
They want full reports. Another thing is we do a lot of pre-production prototyping development, so we'll go through multiple iterations of a part. They're changing slight things, adjusting tolerances based on their tests. So it allows us to provide them with what the real measurements are. They trust it because of the equipment that it's measured on, and it allows them to more quickly develop things. They can trust the measurements they're getting from us. And they definitely want the documentation during that development process. All of our customers in the automotive, defense, and now we're getting into medical and some aerospace type stuff. So it's opened up some new doors for us too, and just having the quality of reporting from both types of equipment.
Well, what kind of requirements are you getting from your customers in terms of what they're looking for in reporting? I know that the software, the user interfaces and the reporting capabilities have really changed a lot in the last decade. So what's driving that? What are people telling you they need?
What they need is ease of use, most of all. Whether that's the hardware or the software, they look for ease of use, and they want an operator who can easily pick up this device as any other tool in their case and use it and get usable data out of it. The reporting is a key part of that. What our software allows you to do, and the Zeiss software as well, is to create those part programs so that when you're running repeated parts, you have the same layout of report for each of your parts. So you can begin to see your trend data so that the operator doesn't have to set up this report, the operator doesn't have to try and figure out how they did it last time and make it pretty. The operator just has to run it. Once you've written that program one time, the report is just as easy as taking the measurements. And ease of use, whether it be on the software or the hardware, you want something that's intuitive. You want something that you pick it up and you automatically know how to use it, and to give you that accuracy at the same time. So we're trying to get our reports that much easier because of feedback from people like Frank at Pratt Miller. We take their feedback into our engineering design room, into our software design room especially, to try and improve our products along the way, to make them more available for you guys.
And what's the FARO software called, or is that unique to each equipment?
The FARO software is CAM2 Measure 10.
Okay.
We do have an open architecture so that if you are embedded with a different software on other equipment, we also allow that software to interface with ours as well. So we partner with certain third-party software providers as well, to try and give everyone access to the portability of the hardware itself in a package that they like, that's intuitive for them and that they've already trained on.
And Frank, Calypso is the software package for Zeiss. Do I have that right?
That's correct.
Okay, tell us a little bit about that. Kind of what's been driving kind of advancements in Calypso.
Things that have been driving advancement in Calypso are, again, the usability, which we've had for a long time. So this isn't new to us. We've had a very user-friendly software for a long time. And as our competitors are developing new software, it's leaning towards something that looks like Calypso. So we're already at an advantage in our software and its usability and its reporting capabilities.
Okay. Let's talk about the Contoura a little bit.
Yeah.
And actually, let's open this up a little bit broader. Either the Contoura or the FARO, have those technologies opened up any new kind of business for Pratt Miller, and why? Why do these technologies help you gain even more business?
Well, obviously, we were talking about the reporting and being able to trust the data from the measuring equipment. So we'll bring current customers or even potential new customers through, and they'll see the equipment that we have, and it has opened up new programs within existing customers. New customers have been impressed with the data that we supplied them. One of the customers, their end user is actually NASA on the part that we made. It was the first kind of part we were given by them to try. And although some things were slightly out of spec, it's a very complicated part. We provided them with a full CMM report on the Contoura, and they were so excited to actually have real numbers that they could trust as to how far the positions were out. They said this is great because we haven't gotten anything like this from any of our other suppliers yet, and it's actually led to a lot more business. It's been kind of eating up a lot of the Contoura's time doing parts for similar programs with that customer. So.
Right. Yep.
And if you have some B-roll on the Contoura, I hope, is that what happens when Pratt Miller's customers walk in, and I believe you guys are like 50-50 right now. Half is racing development.
It's about 60-40 racing to engineering services.
Wow. So just having a Contoura just opens up the door for way more business other than racing. They make this really cool car, but their engineering is so good that they're able to manufacture now and check to the precision that they're trying to make. So when a customer walks in and sees a Zeiss machine, they know that these guys know how to check their parts. They know that the equipment they're using to check their part is highly precise and it does the metrology correct in the software.
Okay.
Yep. Some customers have even gotten a little jealous when they see the equipment that we have from both of them.
Yeah, like you'll walk in, or I'll be at a customer helping with some support, and you'll see them walk their customers through their shop and they'll be like, there's a Zeiss in here? Oh, we must have a good quality department. And it shows a lot.
Okay. Well, let's talk about some of the other equipment that you have here at the show, besides the pieces of equipment that we already talked about.
So we're showcasing two new products here at the IMTS, and the first one is the Mycura CMM. So the Mycura CMM was developed with the idea of a small measuring volume needed with very high precision. So the Mycura features a 0.7 plus L/400 volumetric accuracy, and it features the VAST XT Gold active probe head. So the great thing about the VAST XT Gold is, like most of our other Zeiss probe heads, it does with scanning, and what you get is the active scanning technology. And this specific probe head lets you put extensions up to 500 millimeters and probing systems that are up to 500 grams. So active heads are great for medical because usually they'll make soft plastic parts, and with an active probing system, it really lets you control probing forces and probing dynamics, things of that nature. The next product, newly released product, is our OInspec 322. It's a optical and contact machine for smaller parts. So you get a smaller measuring volume than the original OInspec, but it's specifically designed for vision system and tactile measuring, all in the same measurement run. So you have the Discovery, I believe, V12 lens on there with the same XXT sensor that comes in our standard like Conturas or Acuras.
And the OInspec, I'm sorry, I didn't catch, was that a 2D or 3D measurement?
It's a 3D measuring system. The camera is of course 2D, but because with the addition of the second sensor, the tactile sensor, you now have three-dimensional measurement.
Okay, and again, its application is more for?
Whatever part that's flat and has, well, I guess doesn't make sense. Whatever part that needs both vision and tactile. So you're looking at very small parts, a lot of electronic type parts. Parts that are completely flat we can use on there, two-dimensional. If you have depth though, that's why you have the tactile sensor on there.
Okay, and now back to the Mycura a little bit. I think you said that was, the accuracy was 0.7 L/400?
Yep.
So sub-micron accuracy.
Sub-micron accuracy.
On a, that's That's really small.
Yes. Yeah.
And I think you said the application for that seems to be more obviously small parts. It's got a small volume, but medical device, that sort of thing.
Because obviously things that go in you can't be made wrong. Because
Right.
you know, big old medical lawsuits and things like that.
Sure.
Other customers are using their calibration labs. So if you want to certify artifacts, you need a machine that's highly precise.
Okay.
Yep.
Michelle, what about for you guys here at FARO? What's new here at the show?
Well, one of the things that we're debuting at the show is the newest release of the onboard software for the Edge, the Smart Arm concept, and having that new software that's even more intuitive and has even more functionality to allow you to truly be portable and take those quick measurements right out on your part. Now, one of the things that, leading into our other device, one of the benefits of us partnering with Zeiss rather than competing with them for customers like Pratt Miller is that we both bring different keys to the table. They bring the sub-micron accuracy for those tight engine components, and we bring the portability. So in terms of portability, our other item that we're debuting here at the show is the latest Vantage tracker, and that's the newest FARO laser tracker. It's much lighter and much smaller than trackers were before. In fact, it's 28% lighter and 25% smaller. And the packaging for it is so reduced that you can actually take it on board an aircraft and put it in the overhead bin. So that makes it much better. The laser head itself is only 26 pounds.
Okay.
So we're a smaller size and we're increased range. It's 45% longer range. So you can measure out to 90 meters with this laser tracker. And the size of it gives you that portability, that ease of use to take it wherever you need to measure your race car, to measure an aircraft, or whatever it might be that you're trying to align to. The Vantage also has scanning capability, so that contact scanning. As you drag your SMR over the part, you can take points either through a certain set distance that the operator chooses, whether it be every millimeter, every half millimeter, or through a time-based scan, so that you can take points equally spaced as you move every half second or every second, whatever you choose to set it as. Another advantage of the tracker. And once more on that portability note, it's got integrated Wi-Fi. So as you're moving around with your equipment, it's one less cable to have to worry about because you've got a Wi-Fi connection to your computer.
And I understand it's also waterproof, weatherproof?
Absolutely. It's IP52 rated, which means it can rain on it and dust can be there and it's not going to affect the device itself.
So there, you can use it during a race when it's raining.
Yeah.
And rain never happens during a race, right?
It happens quite a bit.
No, actually,
Makes things interesting, though.
there's a question. I mean, do you ever have to do, I imagine the answer to this is no, but I'm just curious, is during a race, do you ever have to take like measurements like during a race, like something deforms on the car and you need to capture that data for some reason or anything like that?
We typically don't have to, but we could take a FARO arm over there. What we do have is a lot of setup gauges and things like that that we've manufactured in-house that laser alignment and things like that for setting up the suspension. So all of those parts have been inspected, as individual parts on the Zeiss, and then we'll typically measure the entire fixturing or setup assembly using the FARO because it ends up getting kind of big sometimes.
Sure.
The wheelbase of the car and things like that. So we'll actually inspect those setup gauges, and then the race guys can use those on site.
Do you also have requirements regarding the size of the car? NASCAR's big in the South, and I know they have certain size requirements they have to meet.
There's templates that they'll hang on the car when they go through tech inspection. One of the big things that we have tolerance stack up. You got to make sure it's correct to get the full range on your rear wing on the Corvette. They have a maximum height over the roof line. That's mandated by the sanctioning body, and that's kind of one of the things that a lot of guys teams get caught out on and get penalized for, is running their wing too high, because the higher up into the airflow you have it, the more downforce you get, so you get to go faster through the turns. So they really limit that to try and keep all the cars on parity, because we're racing a front-engine V8 Corvette against mid-engine V8 Ferrari, rear-engined flat six Porsche, front-engine V10 Viper from SRT. So there's a wider range of vehicles that they're trying to equalize to some extent to have racing on track.
So there's a lot of actually in the, I think you call it the tech inspection before a race. So there's actually a lot of measurements that you guys have got to be spot on. Otherwise you could be, maybe not disqualified, but I think you said they
penalized. They'll put you at the back of the field, and you put a lot of effort into setting a fast time and qualifying, and then post-qualifying
Be off
inspection.
by that much.
They'll inspect usually the top few qualifiers and then a random one or two.
Okay.
And if you get caught, you get to go to the back. And
So who inspects that and how at the race?
The sanctioning body has check gauges, basically. They're checking ride heights, they're checking profile of the car, where the wing is located off of the car, and things like that.
So it's not just some guy like with a
tape measure.
Sometimes it is.
Depending on the series and what they're checking, I mean, they're not looking for sub-micron accuracy. You know?
Can you give us their number? We'll make sure they get some more repeatable equipment.
Yeah.
We
Dude,
might be
you're
able
off
to
by
do
a
something.
16th of an inch.
Yeah.
So let's talk a bit. We've been talking about the equipment. I'm assuming that as a client, you know, you've got your vendors, Zeiss and FARO and many others, I'm sure. Let's talk a little bit about the importance of customer service. And I mean, I understand you're really just a short distance from both these companies.
Yep, they both have a Michigan-based facility. They're both about 10 minutes away from Pratt Miller, so we can typically, if we need someone on site, they could be there in the, you know, if not that day, the next day. They do great support over the phone, or even the forums and, you know, tech support bulletin type things, and frequently asked questions. You know, sometimes those will even satisfy. We won't even have to bug them, but you know, I'm sure that they give the same level of support to all their clients. We just happen to be very close to their support offices, so we can get live help a little bit quicker. But
and he's right. I mean, we have a team dedicated just to do phone support for the Calypso software, and all our techs are available. They're at the customer's disposal, so they'll hop on the plane whenever you need them. And we are worldwide. We have our colleagues here at the show from Deutschland.
Okay.
You know, we have a global presence.
Okay. Another question just came in. Before I do that, remind you, all of you, that send your questions to techno-live@qualitydigest.com, and we will get them on the air. So, question here. Get back to it. This has to do with Calypso. Are there certain features of the Calypso that are particularly beneficial for you?
Yep, one of the biggest things is, as Frank was talking about, the active scanning. You know, a lot of our parts, we have critical bearing boards. We use expensive ceramic bearings for the Corvette, for instance, and they gain you a few miles an hour on the straights at Le Mans, but the bearing bore tolerances are held fairly tight for them to actually, the bearings to function. So we can actually use the scanning to improve even within our tolerance range to get the best fit for the bearings, to set the preloading for the bearings and things like that. So we'll actually have custom spacers ground based on the measurements that we make. We can show the machinists visually on the screen where the points are, and, you know, magnify that just to kind of show them. And makes things a lot easier communicating rather than drawing hand sketches and them calling, you know, you out on did you do it right kind of stuff. So it's, you know, on the screen you can show them you know, what the actual measurement points are down to the individual points. And you know, another great thing has been the mirror feature. We do a lot of handed parts for suspension, and we only make 2 cars a year typically for each different program. So we'll have 5 rights, 5 lefts of a very complex part. So we'll program one side, mirror it, and just go back through and double check that all the approaches and everything have been mirrored correctly, just as a, you know, sanity safety check.
Sure.
We don't want to have any crashes.
Right.
And then once we do that, you know, it saves us on some parts like a day of programming. On some of the complicated suspension parts like hubs and uprights, or a knuckle for production environment, we call it a knuckle. You know, we do, and also the pattern feature saves a lot of time. I didn't even discover that. One of the guys that works with me did. So he kind of stumbled upon it, and it saved a lot of time on some of the parts we're working on for our engineering services customers as well.
And I think you also mentioned another feature, the ability to program one part but then measure, assuming they're all fixtured up,
palletize them.
Yeah, palletize it. Tell me about that.
So Frank here will write his inspection program for his highly complex racing part that I don't understand, and he has his operator whose job it is to make sure that the other 100 of them you get results for. So they develop a fixture, or somehow put them all on the measuring table, put as many as they can on it, hit it, go, and then go do whatever else they have to do.
So tell us about some of the benefits that you've seen from working with these various types of equipment. I mean, benefits, I guess, in terms, however you want to define it, cost, time savings, more customers, however that works.
Two big things are time savings. You know, in terms of actually throughput with the CNC control, we can set up the Zeiss to run and then go and use the FARO to inspect a mold or something. It frees up the employee, the inspector, to actually go and use some other equipment, go do something else. We're a fairly small company still. We're about 200 employees in Michigan, and we have a satellite office down in North Carolina with about 30 employees down there right now.
Okay.
I could be off on that, but all of our manufacturing is done up in Michigan, and we have to support a wide variety of programs. Our customers come to us because we're kind of like their emergency room.
Okay.
When they need something done fast and done right, they come to us. And so not just the racing, but all of our programs are really truncated time schedules. We're thrashing to get things done. We need to have a quick throughput to get them onto assembly, or a part that's part of a weldment to the fabricators. And we're juggling a lot of stuff. So the big thing is our throughput and our time savings. Has been probably the biggest benefit.
Now, earlier when we were talking about kind of customer responsiveness from both FARO and Zeiss. When you have a problem, they're just right there to help you. But you also mentioned that they listen when you have suggestions for new additions and so forth to the products. I mean, tell me about that.
Like one of the big ones is FARO with the laser line probe used to be mounted on top of the gun portion of the measuring arm. And sometimes it was tough to get into a tight spot in some of the situations we're trying to measure. And then it's actually been now mounted under the gun, like on the handle, basically. It's a quick change as opposed to the last one. So they made a lot of improvements. I'm sure I wasn't the only one making these suggestions, but sometimes you feel like it because, hey, all the stuff that I said would be a great improvement, they've gone and addressed. So.
Well, you are our most important customer.
I bet she says that to everybody.
I'm sure.
The laser line probe itself that he's speaking of, it has a much smaller profile now on the edge arm than it has in the past. And moving it from the top to the bottom of the hard probe also allows you to get into places that you couldn't before because there was obstruction. It was a larger profile, so you couldn't get into those tight spaces. Now you can. And the profile of the laser line probe itself, I think we have some B-roll of it, is so small you almost don't even realize that the laser probe is even mounted. And you can quick change these in and out with just easily removing the laser probe and putting another handle on if you like. And if the handle is still not quite as low profile as you need to get into a space, you can remove that as well and use the arm without that pistol grip handle so that you can get into other smaller places.
And so I guess the same question. I mean, how does Zeiss, I'm sure, kind of solicits suggestions from its users in terms of what can we do to give you features that maybe we don't have just yet? And,
So if you're a Zeiss user, what you should be familiar with is our customer online web portal, where we have a whole message board where Calypso programmers go in there, they ask for help. Along with that, there's a link that goes directly to our German developers, where you put your suggestions for software changes. I'm not going to say improvements, I just want to say changes, because so it might just be some different way to do something.
Sure.
And so all that feedback is taken back and implemented in different software revisions, different releases. So you have the power to change our Calypso software by simply going to our Metrology portal and submitting your request.
Okay. Now, keep in mind, if you have any questions for any of us up here, be sure to send them to techno-live@qualitydigest.com because we're getting close to the end of our show here, so we want to make sure to get your question in if you have them. So is there anything you guys want to just kind of add to our discussion here?
I have something. So,
all right.
We've been just a hardware and software company for a long time, and another thing we sell is a lot of training, and a lot of companies buy our inspection equipment and they'll get a new operator or something like that. So what we've developed for customers like that with their downtime is we now offer contract inspection services out of our headquarters in Maple Grove, Minnesota. So what you get with that is the accuracy of all the machines that we have, that we make. So we have access to all our high precision stuff, all our big stuff, so whatever size part you might manufacture. And we have the knowledge in metrology to do it right for you guys. So if contract inspection is something that you're interested in, you can contact our Maple Grove office and we can set something up.
Okay.
Yeah.
So
I'd like to add something as well. We've been talking about 3D measurement, 3D metrology, but FARO also does 3D documentation. We do imaging or point cloud data on a large scale. We have our Focus 3D product that you can see at our booth as well, and it allows you to take 1 million points per second, very close to 1 million points per second, and scan large objects, basically the size of this room, within a matter of minutes. So we have that ability as well. Everything from the, and once again, portable. That Focus 3D scanner is about 11 pounds. So very small, even smaller in person than you see it in pictures, so come by and see it.
And actually, it's kind of on the same line. Some of the equipment, we have a wide range of equipment that does a great job, but sometimes we'll run into a situation where we don't really need to have something all the time. We've done once or twice gone over to the Zeiss facility in Brighton to have something measured real quick because we couldn't stop what was ever on our machine. So they've been great support doing that. And then FARO will come actually with the laser trackers before we do a new car build. It's typically once a year. So we'll actually re-level all of our bed plates, our steel bed plates, and they'll come in with the tracker and we'll get them level. We'll actually mark on the plates if there is a low spot, so we know to avoid putting fixturing there. We'll actually go back and fill in low spots with a level and things like that, with metal filler and things like that. So it's, we have access to a wide range of equipment we don't even have in our shop, having companies that are like FARO and Zeiss that are the size and have the support networks that they do.
Okay. Well, let me ask a general question. I mean, because this is, I think, what's probably going to be kind of sums up what might be most interesting for our users is, as an end user, I mean, you have to make choices in terms of who you're going to partner with for whatever. I mean, whether it's measurement equipment or anything else that you may have to buy or subcontract out. As an end user, what's most important for you? What are you looking for in a partner?
Well, I mean, the big thing is having support, especially when we're kind of all over the map with the stuff we do. I mean, we're doing racing, obviously, which we're known for, but we're doing, full vehicle builds for defense prototypes. We're doing electric car stuff. We're doing medical device stuff. So sometimes these areas are new to us. We're applying our engineering knowledge and manufacturing knowledge, but the industry we're serving is new to us. So we might, just be learning about certain requirements that are important to them. So sometimes we do run into things where we're not sure if equipment can do something, or, we kind of say, well, someone else has had to have thought of this before, and, we can call up FARO or Zeiss and figure that out. Sometimes we don't even have to. We just have to click around on the software a little bit and look. And, Frank mentioned their forums and stuff. The operator who's been doing most of the CMM operating for the last 6 months or so has used those a lot. Sometimes I don't even know that he's trying to figure something out, and he'll just go on there and do that. And the FARO FAQ stuff has definitely come in handy quite a bit too. And having the personal support also that they offer, lets us know that they have these features that are useful to us.
We have an experienced team of field engineers, applications engineers located throughout the country who have experience not only in racing but in automotive manufacturing, and then every industry that you can really touch, whether it be steel mills, paper mills. And as we gather this knowledge of how other people use the equipment, usually what you're doing is something similar to something someone else has done before. So we can figure it out, and we have those expertise available to Frank whenever he has questions like that. So we can give him the best answer.
It's always really interesting. I mean, this didn't used to be the case. Your answer did not used to be the case. When you would ask somebody what's really important, well, it's all about specs. It's all about does the product deliver the specs I need, and so on and so forth. It's really interesting. That very first thing out of your mouth was support, and I think that has really become kind of the mantra across all industries, including something as technical as measurement equipment. Is as good as the equipment is, as great as the equipment is, Zeiss or FARO, those vendors, if they're not giving you support, then the equipment is. It could become almost a liability because you've spent money on it, and if you can't get support for it, at some point it almost becomes not a piece of equipment you can use.
And that's a big reason why our customers come to us. So we know that how important that is for them. So it's also important for our suppliers, and Another thing is, we don't like to say, we call it dyno racing.
Okay.
It doesn't matter how much power your car makes on the dyno. All that matters is that you cross the finish line and take the checkered flag first.
Yeah, the dyno's one thing.
So
exactly.
we don't like to bench race and things like that. And having actual support. The specs are great, but if you can't use it or you can't get support that can help you use it better, it's kind of pointless. You say, look, we got this, machine that can measure to sub-micron accuracy, but we don't really know how to use it, and they don't really know how to teach us how to use it. That's not, that's not going to work. You need to know how to use your equipment and use it well, and have people available to you that know how to use it well better than you. I mean, they're the experts on it. I use it, and then if I get stumped, I go to them.
And Dirk, that brings us back to why the Zeiss and FARO partnership is so key. I think we both recognize the importance of service to our customers, and by partnering together, we realize that there are certain things FARO is going to bring to the table that's the most appropriate tool for the job, and then there are cases where the Zeiss is going to be the most appropriate tool. And we know Frank is going to be most satisfied if we work together to make sure he gets the right tool for his need.
Right. So,
yes. So, okay, so we're at the IMTS, right?
Right.
And people come here because they want to smoke and deal on their equipment.
Right.
We do have a show special, but I'm wondering if Pratt Miller has a show special on the Corvette.
Oh, yeah. Yeah. Can we drive this puppy home?
I don't know. We'd have to ask General Motors about that, because while we build the cars, they are General Motors cars.
Well, we're almost at the end of our show here, so this is kind of your last chance, and I mean like within the next minute, to get your questions to us. I'd like to thank all of you for being here, and for FARO and Zeiss, this is a fantastic booth. It's like, 40 by, a mile long or something like that. A lot of different equipment in here, and it's been really interesting to go around and see everything that you guys have on display, and just really appreciate you opening it up for us to come in here, and really, Frank, for just a dynamite description of how Pratt Miller is using a lot of different equipment to solve your problems.
And we don't have our own display here, but we do have our car on display. It's been fairly entertaining to me just to kind of stand in the background and see everyone kind of admiring the car, because when you work around it all the time, you get desensitized a little bit, and seeing people kind of smile and light up and taking pictures kind of, it brings me back to when I was that kid going to all the races and driving everywhere, and I've kind of been desensitized to that, so it's cool to see.
Question. I was looking at the car, I think it's on the inside back, there's like a nickel taped to the, is that like to balance the car or something?
No,
precise?
Our drivers and crew chiefs and things have jokes and bets, and they put mascots and things, and the car right now has $1 bet between the drivers who can afford to bet more than $1, but it's a bet on who wins the championship, which actually they're in Virginia at VIR this weekend. If anyone watches, they'll have it, I think, broadcasting live stream on ESPN.com.
Okay.
And then the live race, I believe, is aired on Sunday. But we're in the lead, 1-2 in the championship.
Awesome.
Four cars in the lead in the GT class, with 3 cars in second. And we got 2 races to go. There's a 4-hour here at Virginia International Raceway, and then there's the 10-hour race down at Road Atlanta to end the season. So we're looking for good results from both of those.
Right.
And our preparations are good, but once you get out on the track, you never quite know what's going to happen.
That's right.
Got to be prepared for anything.
Okay. Well, again, Frank Valdez.
Dirk.
Thanks for being on the show, man. Really appreciate it, and the rundown on all the Zeiss equipment. Definitely Frank Wilson from Pratt and Miller Engineering.
Yep.
Awesome. Thanks, buddy. And Michelle Edwards from FARO Technologies. And thanks to all of you guys as well for tuning in for this episode of Technology Live. Hope it was informative for you. Hope you got a lot out of it. And kind of the takeaway on this, I think, is that when you're looking for partners like Zeiss and FARO who are really willing not only to give you a good product. I mean, good product is important, but what you're really looking for, you heard it right from Frank here and Pratt and Miller. First thing out of his mouth was customer service, customer support. That's what you really want in any kind of partner, whatever any kind of equipment it is. So once again, thank you for joining us, and we'll see you at the next Technology Live.